Hello students, today we are going to discuss how to determine the density of the solids. Solids may be in regular shapes or may be in irregular shape. Some have the definite shape and some have the not definite shape, or it may be lighter than the water or may be heavier than the water. If the solids, whether it is regular or irregular, heavier than water, then it will be sink in the water, and the body or a solid which is lighter than the water, whether it is regular or irregular shape, it will be or it float on the surface of the water. So how we can determine the density of these such a type solids? So first of all, regular solid means having the definite shape. So I mean to say, for example, cube, cuboid, cylinder, sphere, their volume can be measured by knowing the dimensions of such a solids and by applying appropriate formulas. So for example, if we have the cube, you know that what is the meaning of the cube? An object which have the same length, same height and same breadth. So its volume is length into breadth into height. That means to say all the sides are equal, so it means beside the whole cube. And if it is in the shape of the cuboid, then the length into breadth into height, we can use this formula and find the volume of the cuboid. And if the body is in the shape of sphere, then you know that the volume of the sphere 4 by 3 pi r cube. So this is the formula for to determine the volume of regular solids, because they have that definite shape. And for the mass, we can measure the mass by beam balance. So this is the diagram of the beam balance. Nowadays we are using electronics balance also for measuring the mass of the object. So we are required mass and volume for the regular solids, and we will put the formula density equal to mass per unit of volume, and we can calculate the density of the solid. But what happened if we have the irregular solid? Irregular solid mean to say that they have not a definite shape. For example, a stone piece, a glass topper, and it should be insoluble in water. वो जो solid है वो water में insoluble होनी चाहिए. It is do not dissolve in the water. Shape कैसी भी हो सके. और it may and denser than water. तो वाटर से डेंसिटी भी ज़्यादा चाहिए, वो इरेगुलर शेप की होगी, इनसॉल्युबल वाटर हो और डेंसर हो वाटर में. सो उसका जो मेन पॉइंट इज दैट कि वी हैव टू कैलकुलेट द वॉल्यूम ऑफ ए सच ऑफ इरेगुलर शेप ऑफ द सॉलिड. सो देयर आर द डिफरेंट formulas, different method to calculate. We will in the next session we will discuss the that method with the help of the activity. Then we will perform that activity to calculate the volume. And the mass, again we can use the beam balance for measuring the mass. So for the volume of the irregular solid, we will use the formula displacement method. And this displacement method is of two types. One is the measuring cylinder, with the help of the measuring cylinder, and the second is overflow can, that is called also Eureka can. So let's perform some activity, that is activity 1. We are going to measuring the volume of the irregular solid which is heavier than water and insoluble in water. For that we have to require some material. It is a quite simple material, a small piece of stone, a beam balance, a thread, a measuring cylinder, and water. So these simple things are required for this activity. So first what we have to do, now look at that, this is the measuring cylinder, and there is some marking on this cylinder 0, 10, 20, 30, 40. It is showing the volume of water in the measuring cylinder in milliliter. As we discussed that 1 milliliter equal to 1 centimeter cube, as I told you before that. So what we have to do, it is a quite simple activity. So pour some water in this measuring cylinder. When the water level is steady, then note the volume. Note this point, that is it is denoted with the 50. So this is the V1, that is the volume of water. We will write like that. So V1, volume of water. Now what we have to do then the next step. So tie a thread around the stone and gently immerse it into water, and the stone piece should be completely immersed in the water and should not touch the walls or the base of the measuring cylinder. These are the some precautions which we have taken during this activity. So keeping your mind, now you will find out that because this stone is heavier than the water, it is sink in the water, then what will be happen, the rise of the water level will be increased, the level of the water will be raised. Look at that, without stone it is at 50, now its volume it at 70. So this is the volume V2. So V2 is the volume of the displaced liquid. Now look at that, first volume V1, that is denoted with the 70. So this is the 70 milliliter. Now volume V2, now you are looking at that, this is the second measuring cylinder, that is denoted with the 70. Sorry, here this is the 50 milliliter. Now here is the 70 milliliter. So what is the change in the volume? So volume of stone, we have to find the volume of the stone of the regular shaped body. So volume of stone will be equal to the volume of displaced water. So what is the water displaced by that stone? The volume of the displaced water will be equal to the volume of the stone. And how we can find it to that? This is the simple formula. So volume with the stone is V2, without stone that is minus V1. So what your answer? 70 minus 50 equal to 20 milliliters. So this is the example, only example. So with the help of beam balance you can measure the mass of such a solid, irregular solid, and you can measure the density. So we have to measure the density. So density will be equal to mass per unit volume. So volume equal to m over V2 minus V1. So with this simple activity you can calculate the density of the irregular solid, I mean to say having a irregular shape. Now another activity, that activity 2, we will perform same thing, that is we will determine the density of the solid, but now this is the another method with the help of the Eureka can. So it is a simple cylinder with the spout, that is called the Eureka can. So what is the difference between this activity from the latter? So here we have again stone or piece, but it has a large area, you can say that it is larger in size, which cannot be immersed in a simple measuring cylinder. So we are going to use this activity for the larger solid object which have the irregular shape again and heavier than the water. So this is the very simple activity. So what we have to, this is the wooden block, we will put the Eureka can over there, and there is the measuring cylinder. So first what we have to do is pour some water in the Eureka can till water starts overflowing through the spout. Then after that, when the water stops dripping and water level in the can becomes steady, remove the measuring cylinder, then empty it and get it dry again and place it under the Eureka can again. So now the water level is steady. Now what we have to do, the next step is very easy as we did in the last activity. So again tie a thread with the stone and fully immersed in the water, this in the Eureka can. So again the precautions are that it should not be touched with the walls or the floor of the this Eureka can. So what will be happened, again the water will be raised up in this Eureka can and it start overflowing through the spout and dripping into the measuring cylinder. So look at that. Now when the displaced water overflow through the spout and it is collecting the measuring cylinder, when the water stops dripping out from the tip of the spout, then at that time note the volume of this liquid. So look at that, it is 40, that is 40 milliliter. Again it is in milliliter, and we will calculate the again the volume of such a type of object. So it is again very simple. So volume of the displaced liquid, so this is the displaced liquid which is collected in this measuring cylinder, is equal to the volume of the solid, this stone. So that will be equal to the V, and we again measure the mass of the stone with the help of the beam balance. Now put in this formula, that is density equal to mass per unit volume, and we can measure the density of the irregular shaped solid, and which is larger size than that of other, which cannot be dipped into the measuring cylinder. So with this method we can measure the density of the solid. Again we can use this formula for substance whose size of is large and immersed in measuring cylinder is quite difficult. So we will use this activity. Now we have the activity 3. Again we are going to measure the density of the irregular solid, but what is the main point? This is lighter than water, that is which will be float on the surface of the water. So it is quite simple activity. So again we required two measuring cylinder, only one measuring cylinder, and a thread, a stone, water, and a beam balanced. So what is going on? Take a small piece of cork, that is a cork, it is very lighter than that of water, which is float on the surface of the water, and especially used as a glass topper in the bottles. So in the neck of the bottles it is always a piece of like a wood, but it is actually cork piece. So we are going to measure the density of such a type of irregular solid which can float on the water. So what is the activity? So first pour some water in the measuring cylinder and note their volume without stone. Note its volume, let it is V1. So for example its volume is V1, that is equal to 40 milliliter. Now what we have to do, again tie a thread with the stone and immersed in the water. Then it's again water level will be rise up, that is water will be displaced in the measuring cylinder. Now this is the volume V2, that is equal to 60 milliliter. Now what we have to do, gently immerse the stone in the, first what we have to do, to remove this stone from the measuring cylinder. Then after that gently immerse the stone with the cork in the measuring cylinder again. Then you will note down that the level of the water again rise. Now this is the cork which is tied the same with the same thread, then its volume increased. Now we have the another volume, that is V3, that is equal to 70 milliliter. V3 equal to 70 milliliter. Now you will find out that there is a change in the volume. So what is the change in the volume? What is the volume of the cork? So it is quite simple. So volume of the cork will be equal to, so let it take it V, and V equal to V3 minus V2. So we can find the volume of the cork with this formula, that is V3 minus V2. So V2 is the volume of the water with the stone, and V3 is the volume of the water with the stone and with the cork. So cork also displaces the water, and we find from this formula V equal to V3 minus V2. So for example, as we know that V3, we have taken the V3 is 70 milliliter and V2 equal to 60, then it is equal to 10 milliliter. Again with the help of the beam balance we can measure the mass of the cork, and simply we are going to use the formula, that is mass per unit volume. Then we can find the again density of such a type of irregular solid which is lighter than the water. So with these activities we can find we can determine the density of the irregular solid bodies which are which may be lighter than water or which may be heavier than the water.